start the recording just because I want to make sure that everybody at home can, if they don't make it today, watch the video, because it's going to be important that we actually watch this lesson at some point. So today, we're going to be talking about similarities. So my people that are at home that have the textbooks, the warm-up the warm-up today is not in the textbook. So I want you to follow along with me on the slideshow. And then the first activity that we're going to do is actually going to be in the textbook. So for now, I want you just watching along with us. And we're going to sort of talk through this activity, okay? So I'm looking at our learning targets for today. So for today, we're going to be able to apply a sequence of transformations to one figure to get a similar figure, right? So what's a sequence of transformations? What do we remember that term, sequence of transformations? Jocelyn. So it's an order, right? So they're in a specific order. Oh, let me pull the chat up. Sorry. Let me just put the chat up to that. So for the warm-up, no. Actually, I'm not even sharing my screen. So I'm sorry, guys. Let me share my screen. And we will get started. So we are sharing, and here we go. Sorry, guys. So we are talking about a sequence of transformations. There's a specific order that we're going to be doing them in. Good. What else do we know about a sequence of transformation? What does a sequence of transformations mean? Joe?
There are a lot.
There's a lot. There's going to be more than one. Very good. So a sequence of transformations is there's going to be more than one. So we're going to be looking at moving a shape. We're going to be looking at dilating, translating, reflecting, rotating a shape, and doing multiple ones to get from one shape to the other shape. Good. And we're going to use a sequence of transformations to explain why two shapes are similar. If we remember back, that word congruent meant same what, same one. What did we know about those two shapes? Joe?
Same side length and same angle.
So if they're congruent, it's the same side length, right?
Oh, and same angle then.
So congruent was angles, side lengths,
Same.
length, yep. Shape. What else do we remember about if we said two shapes were congruent? What else? The sides. Very good. So the angles were the same, the side lengths were the same, the shape was the same. Now we're going to be talking about, we're throwing into the mix this term called, oh, I don't know why that didn't on it, but dilations. If we remember, a dilation takes a shape or a line and it makes it bigger or smaller, right? So now we're going to talk about this term similar when we're talking about throwing dilations into the mix. Similar means same shape, but different size. So the side lengths aren't going to be the same anymore, but the angle measures are. It's going to be the same shape, but it might be either bigger or smaller. Does that make sense? So congruent is same size, same shape. Similar is just same shape. Okay. It'll make more sense once we look at it for here. Okay, so when we look at these two shapes here, we're going to say, what do we notice about these two shapes here?
They're just not the same size, and they don't have the same side length.
So they don't have the same side lengths. They're the same shape,
They're not the same size.
but a different size. Good. That's a good thing to notice there. They're the same shape, but they're different sizes. So let me just this door stop. I don't want to have door slam. It has a mind of its own. So we have the same shape here, but it's a different size. And if I was going from the blue shape to the green shape, what could we say about the scale factor? Who could give me a guess of what the scale factor would be here? If I'm going from the blue one to the green one, who could give me a good guess?
8.
8? Okay. Why did you say 8?
Because I think it's going to be like double.
because it got double. It got, well, in general, we can say about the blue shape to the green shape, what happened? It got
Longer.
longer, it got bigger, right? So we're saying, we could say it has a scale factor of 8 because it got bigger. What if I had said, let's go from the green one to the blue one? What could we say for a scale factor for the green one to the blue one? What do you think?
1/2.
1/2.
1/2, it got smaller. So a scale factor, if we went from green to blue, could be 1/2 because it got smaller. Awesome job, my friends at home, and Shelby, the tag teamed on that one. Perfect. So now we're looking at this guy. What sort of moves do we think could take us? Like what might we have to do to get from the blue shape to the green shape now? What sort of move do you think I would have to do? First thing, what's one thing I'd have to do, Jocelyn?
Find the point.
Find a point, right? So that we could use this point right here. But what sort of transformation would I have to do to this? You don't need to be too specific by saying like around point something or 90 degrees. What do you think we might have to do here? We might have to rotate it. Very good. Because we have these 2 points are pointing up here and they're pointing to the side over on the new one. So it's going to have to rotate some sort of way. Good. What else might we have to do? Do you think if I rotate it, this shorter piece here would be pointing down over here, but the shorter piece is up at the top over here. So I don't know if just the rotation, oh, sorry.
Sorry to interrupt.
No.
Is this your group?
Yes, that's
Okay,
fine.
you just have to go back and update for,
Okay,
if you haven't done that already,
okay,
for the 20s. That one's just recent. Some of the
Okay.
people we have is not recent.
Okay.
But, so you just gotta update that one.
Okay.
Okay,
okay,
and then give it to Jen, we're gonna ask.
okay,
All right, thank you.
okay. That was from Tuesday. I think I went back and hit them that yesterday. Okay, sorry guys. What did you think, Edgar? So we might have to rotate it and then we're gonna have to reflect it as well, because if we rotate it, it would bring, oh, let me rewrite this, guys. So if we rotate it, it would look like, sort of, right? Like this, the shorter triangle would be pointing up here. And then now to get it over there, we would have to reflect it. And what other move would we have to do here? Huh?
Rotate it.
We'd have to rotate it. Very good. Rotate. Reflect. And now we're missing that most important one. I went from blue to green. It went from,
Translation. That's what I mean.
when it gets bigger, what do we call that? What's that move called? A dilation. Very good. Nice job. We would have to dilate it. Okay, and by a scale factor, that's going to be larger than 1. So now what I want you to do, if you are at home and if you're in here and you have a textbook, I want you to open your textbook. Okay, if you are at home, you're a CDL, you don't have your textbook yet, I want you to watch along with us. So let me just scroll so I can get to the activity. And we're going to be looking at, if you're in your textbook, open up to lesson number 6. And it looks, so lesson number 6 in your text, like this. People at home, it looks like this. And flip it 1 so that we're looking at our 2 triangles. We're looking at our 2 triangles like this, okay? So if you have your text, open it to chapter 6, and it has the 2 triangles on it. We're going to be writing a little bit. We're going to be doing a little bit of this together. We're also going to be doing a little bit of it on our, so you're not going to, if you're at home and you don't have your textbook, you don't need to open up this GeoGebra app. We're going to do it together. So just make sure that you are on the Zoom screen so that you can see me sharing it, okay? So if we look at this shape right here,
We'll listen.
lesson 6. Okay, so I have this shape right here. It's the orange shape is the one that we're starting with. Okay, so I have my orange triangle, and I want to do some sort of sequence of transformations that will take the orange one to now fall on top of this green one down here. I just threw it on here. So what are some things, let's throw some ideas out. What are we gonna have to do here to get that orange one to fit perfectly on top of that green one? Camilla, what's one thing we might have to do here? You don't need to have your Chromebooks open, they can be closed.
Find a scale factor.
We might have to do a scale factor, but Camilla, what do you think we might have to do here? We might have to translate it, that's good. Very good, we might have to translate it. What else are we gonna have to do here, Mila? You don't need to look in your book, look up here. We're going from the orange one down to the green one. What would I have to do to that orange shape to get it so that it fits perfectly on top of the green shape? We're gonna have to translate it, like Camilla said. What else are we gonna have to do to it? Good, we're gonna have to dilate it. That's our word, we're gonna dilate, very good. So if we're going from our green one to our orange one to our green one, people at home, I want you to throw in the chat, what do you think the scale factor is gonna be? People in here, I want you to think, we're going from orange to green. What do we think the scale factor is gonna be? Who can give me an estimate of what they think it's gonna be? Melissa. Nice job, you. Huh? So we said the scale factor from orange to the green one down here. Melissa said 2. Hector said 1/2, so did Giovanni. So we have 2 and we have 1/2. What do we think?
Less than 1.
Less than 1? Was that Landon?
Yeah.
Awesome, Landon. And why is it going to be less than 1, Sam?
Because it's getting smaller.
Because it's getting smaller. Sorry, Sam. We're going to say it's going to be less than 1 because it's getting smaller. So we can't say it's going to have a scale factor of 2 because 2 would mean it was getting bigger, right? So let's figure out if we can figure out what the exact scale factor is. So I'm going from, let's look at some of these side lengths. So if I'm looking at this length right here on the orange triangle, which side on the new one, 1, 2, or 3, will correspond or match with it?
3.
Who's that?
Me.
Nice job. Why do you think it's going to be 3?
Because they're the same shape, but just different sizes.
But why did you say that they match up though?
Because if you were to translate it, they would, the sides would match up.
Exactly, because they're the corresponding or matching sides. Very good. So Muka, I just want you to try to follow along, my friends. We came in a few minutes late, so I just want you to give it your best shot, okay? So I have this side length here that matches or corresponds with the one down on the bottom there, number 3. So, and what's my side length on the original one? How many boxes long is it? The bottom here. How many?
2.
3.
On the original.
3.5.
4. 1, 2, 3, 4. 4 boxes. 1, 2, 3, 4. And then how long is the corresponding or matching one on the new one? On the image. It is 1 too long. So this original length, this 4 times what number is going to get me 2?
1/2.
1/2. Very good. So the way that we can figure out what our fraction is going to be, our scale factor is going to be, is by finding corresponding side lengths and saying to yourself, what do I have to multiply by to get from one side length to the other? Does that sort of make sense? Cool, wonderful. So, awesome. So we have a scale factor of 1/2. Good. So when we dilate by our scale factor of 1/2, it would take us to a new point here, and then how tall would this side length be after my dilation of 1/2? It's 6 tall now, so what would half be? 3 tall. Nice job, Edgar. It would be 2 long and 3 high, and then I would connect them to make the triangle. I don't know what is going on here. Let me move that back. I just need to hit the back arrow and it will work. I'm telling you guys, this is running better than it did last grade, so do not fret. So we would connect them to make this, this is what it would look like after my dilation by 1/2. So then now what's my next move if I want it to get to fall on top of that small guy down below?
Translate it.
Translate it, and Landon, what direction would you translate it?
Down and to the right.
Down? How many would we translate down?
3.
1, 2, 3. That's not bad, okay. So we would translate down 3 units. So if we translate it down 3 units, it would now fall here. Can I have, Tiffany, can you unmute and now tell me what my next move would be?
Translate it 2 to the right.
Translate it 2 to the right. So I'm going to start here. I'm going to move 1, 2. So
Oh, my bad.
let's fix it. Go ahead. How many would you?
1, 2, 3, 4, 5, 6. That's 6, right?
1,
6. I meant 6.
3,
2, 3, 4, 5, 6.
4.
4, 5, 6.
We'd move it 4 though. Let's see why. Because we're taking our corresponding, so we take this vertice here and we want to make it fall. We want to count its distance to get to here. Right? So it would be 1, 2, 3, 4. So we translate it down 3 units and to the right 4 units. And our first move, which I didn't write down, was dilate by a scale factor of, what was it again? 1/2. 1/2. Very good. So in your textbook, I want you to, at the bottom of this page here, I want you to write down our 3 steps that we took to get from this bigger triangle here to the smaller triangle. So first, we dilate by a scale factor of 1/2. Then we translate down 3 units and translate right 4 units. Okay? Very good. Nice job. Fantastic. How you doing, Joe? Fantastic. Keep it up, my friend. I love all of this. Before you're keeping yourself. Love it. Keep it up, Lady Jane. How you doing? I like you do that. Okay, fantastic job, guys. So that was number 1. Now, the next piece, kind of crazy. When they copied the book, they left out a page for some reason. So the next one, we're going to do completely, not in your textbook, up here. So let's take a look. I'm going to move into the next activity here. And you know what? I kind of like doing this activity together as opposed to like the way that I was originally going to do it, because I think it allows us to have a little bit more of a discussion. So let's take a look. If you're on the slides, we're going to slide down to slide number 8. I don't need you to insert anything here because we did it together. So we're going to just slip and slide right down to slide number 8. So it says we need to hexagon A, B, C, D, E, F, and hexagon H, G, L, K, J, I are similar. Find a sequence of translations, rotations, reflections, and dilations that shows that. So we need to find our sequence of transformations that takes it from A, B, C to G, H, GHIJKL. Oh, yeah. So you do that by clicking on the image. Let me open up the Sesmos picture. And we have this guy here. So we're going from the blue one to the orange one. Hector, I want you to grab your computer. I want you to come back to your chair. Okay? I think you're actually perfect. So we're going from this blue shape here, number 1, to the blue shape here, number 2, or the orange shape here, number 2. Okay? So I want you guys to think at home. I want you to tell me what is a move in the chat. Tell me in the chat what move is going to take it from the blue shape to the orange shape. There's going to be a sequence of transformations that takes me from the blue shape to the orange shape. What do we think might be one of those moves?
A reflection.
Oh, a reflection? Okay. Sam, what do you think? And why do you say a dilation? Very good. So he's saying a dilation because the shape is getting larger. Good. So we might have a reflection, a dilation. What else might we have to do here? Do you think there's going to be a rotation?
No.
No? Why do you think no, Sam? Good. So if we do a reflection, it's going to flip us over. We don't have to rotate it. Good. So we're not going to do a rotation here. What else might we have to do here? A translation, because he's all the way up here. We want to make him be down here now. Good. So we're going to have to translate him. I don't know why I'm assuming gender. That's kind of rude. Because we don't know. Any result. So we have a reflection, a dilation, and a translation. What do we want to do first? Joe, what do you think?
Reflect across, let's call that line A.
Line A, good. So we have line A, and he's saying that we need to take this shape right here and reflect it across that line. Good. So remember, when we do reflections, we keep distances the same. So the distance from the line of reflection, to this side is how many boxes?
3,
1,
2.
2, right? So now when we flip it to the other side, we're going to count 2 out, 1, 2. And that's where this side is going to be. Let me go red. Right? And then how many to the right am I going to have to draw that box?
2.
2. Good.
What the heck is
Whoa,
that?
what just happened? That was really weird. Sorry about that, guys. I don't know what happened, but we'll try it again. Oh. Okay, so
That was so weird.
that was like scary. Okay, so we went R2. Good. I like that we were able to stay on track with that. Fantastic. So then Jocelyn said it was going to be 2 there. And then how many tall is it going to be up?
3.
3. And then what am I going to do here next?
Go over 1.
To which way?
Left.
Left 1. And then
Down 2.
down 2.
Over 1.
Over to the left 1. Good. So I just, oh my gosh. You guys just helped me reflect that.
You're welcome.
Oh my gosh, scary. I honestly, listen, I did that with the last class and they were like, hummus? What are you asking me to do? And you guys just did that fantastically. Awesome job. Did everyone see how we reflected that?
Yes.
So first we started with a common distance, right? So this line right here was 2 away from my line of reflection. So I had to bring it 2 on the opposite side of reflection. Okay, and then I had to just take these common distances and draw the shape. Okay, so I reflected it. Boom. Now, what's another easy one that we can do next? We can translate it. Shelby, what direction are we gonna have to translate this guy? Or actually, we'll work on this. Huh? If you want to stand up and come stand on the other side of the board, you can do that. You can stand like on the far side of the board, if you can't see it.
I'm good.
Okay. Melissa, what do we have to do here? We're gonna have to translate it down, okay? Now, Camilla, how many units are we gonna have to translate it down? Camilla's got this. She's counting. She looks super focused. Well, can I help you count? So we have to translate this shape down, right, Camilla? So we're gonna take this vertex and we're gonna translate it down until it falls and hits this vertex right here. So we gotta count it. 1, 2. How many did we translate, Camilla? 6 down. Very good. Fantastic job. Listen, this stuff is hard. You're giving it all. I love how focused you were and you were like attempting. Yeah, I love it. Well, not that like it was really like a bad attempt, but it was good. It was fantastic. Good, so we translated it down, and so it's gonna fall, now it's gonna fall here. And now, my last piece is I have to do a dilation. I want you to think now, what do we think the scale factor? Throw it in the chat if you are at home. Throw in the chat what we think the scale factor is gonna have to be this time. Milo, what do you think?
Oh, geez, we're going bigger, right?
Well, we're going from the blue one to the orange one.
So there.
So we're going bigger. So what do you think?
I know.
I'm gonna get a few ideas from people.
3.
22.
I say 3. I got
Did
3.
Edgar say 3?
I said 3.
Okay, and Hector said 3. So Joe said 4. What else are we thinking? Camilla, what do you think for the scale factor here? Landon said 2. Which one? 2? Okay. Couple people said 3.
Well, just get
Landon's excited. Landon's excited.
4, 6, 8, 10.
So we have 3, we have 2, we have 4. Now we're gonna do some investigation.
Or 3.5.
And we're gonna figure out, we're gonna actually make a decision. What do we think this scale factor is gonna be and how can we find it?
3.5.
No, we're not doing fractions, that's crazy. So what we're gonna do is, so we're gonna find a side on our original shape. Let's grab this guy here because it's 1, right? And then we're gonna find the corresponding or matching side on the new shape, which would be,
Right there.
which one? I'm gonna stop.
Stop.
You
Go
think
down, go
this
down.
side, oh, down, okay,
Whoa. Down.
down,
Yeah.
or this one?
Yeah.
Okay, so we think these two are corresponding or matching sides. Good.
Yeah.
Nice job, Landon. So what's the distance? What's the length on the smaller one?
2.
Well, no, this
Half.
corresponds.
Oh, 1. I'm sorry.
1, right?
Oh my God.
She's really into it, okay? So it goes from a distance of 1 to a length of how many on the bigger one?
3.
3. So what number do I need to multiply by to get from that smaller distance over here to this bigger distance right here? Shelby, what do you think?
Why are you keep calling on me?
Because what number do you need to multiply 1 times 3 by? 1 to get 3 by. Sam, what do you think? Are you modifying your answer? Scale factor of, we have a scale factor of 3. So once again, we did 3 moves to get to where we were. We're gonna rewrite those moves right now. I'm gonna move the chat. So the first move that we did, what was the first move that we did? We reflected, okay? We reflected across, what did we name that line? A. So we reflect across, ooh, geez, that's weird. ACROSS line. A, where I want you to be writing this, if you have your textbook, I want you at the bottom here. It's a really big space down here, so I want it on the right side of your page. In your textbook, I want you writing down the sequence of transformations down over here. What are the sequence of transformations? First, we reflected across line A. What was our next move here? If we think back, what did we do next? We went down, we translated. Down, how many? How many boxes did we translate, Camilla? How many did we have to move it all the way down? 6. Fantastic. We translated down 6 units. Okay. And then our last move. Can I have Giovanni unmute and tell me what was our last move? Do you know, Giovanni?
You reflect it. Did you already say that?
So we reflected it, good. We wrote that one right here. Reflected across line A. Then we translated
Right.
down 6. What was our last move?
You dilate it with a skill factor of 3.
Yes, Giovanni! Highlight by a skill factor of 3. Very good. These need to be written down either on the slides where it says the sequence of transformations or in your textbook at the bottom of that page. Okay? So this evening, we do not have any homework. I'm being nice and getting us into live stream. We're starting the live stream this week, so I figured get over the anxiety of not giving you more anxiety by giving you homework. Is that right? Like, do you think that's okay?
Yeah.
Am I being nice? I think that's
Yeah.
fine. So homework will start next week though.
No.
It's gonna be 20 minutes of Alex time every day,
Oh,
or it might be like 3 problems on it. So
Okay.
everything will apply. So you don't have to do the exit ticket. Wait, I'm gonna wait. There's a cool down on the last slide. We went through this really detailed in class today, so I'm not gonna have you do that exit ticket. Tomorrow there will be an exit ticket though. Question? No? Okay. So my friends at home, please make sure you put your textbook back in your backpack if you're coming in tomorrow. We will need it in class tomorrow. People in class today, please put your textbook in your backpack for tonight. People at home, you can turn in the slides. There's nothing that you need to add to them. CVL can turn them in as well. Does anybody have any questions for me before we move on? Shelby? 45. We have, you're gonna have 5 minutes free at the end. Okay? So my friends at home, fantastic job. I will be posting this video for everybody to watch if they missed it today. Does anybody have any questions for me at home? No? Okay. So my CVL friends, make sure that you are logging in tomorrow as well, because I will be live streaming every single day. I will see you all tomorrow. Have a very nice day, okay, guys? It was good to see you. Bye.
Bye, have a good day.
Bye. Bye, Rashem. Bye, Destiny. Okay. So, why is it so that they can chat with everybody? Interesting. Wonderful job. So, ladies and gentlemen, let's take a look at this cool down experiment. You're not going to do it. We're going to do it together. I want to have one more example for us to look at. So, Elena gives the following sequence of transformations to show that the two figures are similar by transforming A, B, C, D into E, F, G, D. Okay, she said first, dilate it using center D and a scale factor of 2. Do we agree with the fact that we would dilate it by a scale factor of 2?
Yes.
Okay, so let's look. We're going from
Yeah.
the smaller shape here
That depends if we're using.
to the bigger shape. It doesn't depend, it's yes or no. Would we dilate this by a scale factor of 2?
Yeah.
Olivia, why do you think that? Let's listen.
Because if you look at the side diagonal,
Yeah.
it looks like it got bigger by 2.
Okay, so you say, let's look at an easier distance that falls on perfect boxes here. Is there a side length here of this that falls on perfect box edges?
Yeah.
The bottom here, right? The bottom AD is 1. How big is it on the other one?
2.
2, very good.
Yours.
So Carter, what's the scale factor gonna be?
2.
2, because 1 times 2 gets me this new distance of 2. Very good. So it would be a scale factor of 2 using D as a center of dilation, and it would take you out. 1 second. Right, and then it would be 2 and then here. Oh my gosh, Mr. May. No.
Still good.
It looks fine.
Ish. It works. Oh, because I didn't extend the bottom length 1. Good. So then it says reflect it using line EH. This bottom one, is that the line that we would reflect over? Where would we reflect? Would we reflect it horizontally, up and down?
Yeah.
Or would we reflect it vertically, left to right?
Vertically.
We would reflect it vertically. The reflection that she chose is incorrect because we're not going in the right direction. Okay? It said reflect it up and down, but we should really be reflecting it vertically or side to side. Okay? So, ladies and gentlemen, my friends at home, we do not have any homework this evening. I'm going to be starting homework on Monday, so be aware of that.
Why do you have to bring that back?
Because it's a thing that happens. Because normally I was giving you at home work for the days that you were at home. So that's basically homework. So I'm going to start homework on Monday. Please make sure that you join our live stream again tomorrow. Textbooks are going to be used tomorrow better than they were today. And awesome job today. Today was a little bit, we threw a monkey wrench in a couple times because it was a little bit challenging, but you guys all worked really hard. I know that this lesson might have seemed a little bit silly, but you guys have been giving me answers that are telling me you're understanding this. So we're good. I'm not concerned that this lesson was a little bit crazy today because we got everything that we needed to get out of it, okay? So my friends at home, you guys are all set for today. Please make sure that after lunch you come back and join because you will be moving on to your next class then. If you have questions for me, let me know. If not, you can turn in the slideshow and you will have a good day. Awesome job.
We don't need to put anything on the slide.
Nope, nothing on the slide. Turn it in. Have a good day, guys.
Oh, you don't have to fill in.
You're well, Sawyer. No, you don't have to fill anything out. We did
Bye, Carter.
Oh, he's saying bye to Carter. Saying bye.
How do I shut this off?
So everybody,
Bye, Ethan. And then
so we did this lesson today because the technology was a little bit weird, but also I think that this lesson was okay to do.
is that person even listening? A little.
Haley, I think she was, yeah. So why don't we, because she was giving a lot of answers as we were going through, so why don't we get ready for lunch? We're going to head down in about 1 minute.